Class example 2.2.2, determine each product. This time we're going to take a binomial, which is a two-term set of brackets, and r minus 4, multiplied by a trinomial, which is going to give me that 3r squared plus 8r minus 6. I'm going to do the distributive property one more time. I'm going to flip it though this time because there's 3 terms in the second term and only 2 in the first, sorry. And the second one I'm going to use that claw again. So this time for the distributive property in question A, I'm actually going to write this as 3r squared plus 8r minus 6. So all I've done is rewritten this second term with some spaces in between. Now, I kept the negative signs. Notice that I've kept those signs with the actual terms themselves. And now what I'm going to do is I'm going to use that distributive property, and I know that everything in that first set of brackets has to get multiplied by the second set of brackets. So I can actually distribute that r minus 4 to each of those 3 terms in that second set of brackets. And when I do this, I end up getting a 3r squared times an r, a 3r squared times a negative 4. So I get 3r cubed minus 12r squared. I'm going to do the same thing, but this time I can actually kind of look at it as positive 8r multiplied by r and positive 8r multiplied by negative 4. So I see a positive times a positive is going to stay a positive. I get 8 multiplied by a 1 technically here, and then r times r. Next I get a positive times a negative, and 8 times 4 is going to equal to 32. And I have a single r here. It's not being multiplied by any other r's. This time I get to look at this as negative 6 multiplied by r and negative 6 multiplied by negative 4. So that's going to give me negative 6r plus 24. Now, because I had so many more terms going on here, I have a lot more terms here that I have to be careful when I'm collecting my like terms. I can see I've got 2r squareds and 2 r's, but only one constant and 1r cubed. So I'm going to take the 3r cubed and keep it the same because it's got no partners. There are no like terms. Then I'm going to take negative 12r squared and add 8r squared, and so that's going to give me a negative 4r squared. Next, I'm going to take negative 32r minus 6r. That's going to give me negative 38r. And because 24 doesn't have any other like terms that are constants, we just add that 24 at the end. And I can see when I multiply the binomial times the trinomial, r minus 4 multiplied by 3r squared plus 8r minus 6, I'm left with a term that contains 4 terms, and that's 3r cubed minus 4r squared minus 38r plus 24. Question B, I'm going to go back to the claw method. I am going to take 5x and I'm going to multiply it by everything on that second set of brackets. And then I'm also going to take negative 3 and I'm going to multiply it by everything in the second set of brackets. This time it doesn't quite look like a claw. Or maybe it's like a double-edged claw, because I actually have to distribute that 5x to all 3 of those terms in the second set of brackets, 2x squared as well as the negative 6x and the 12. And then I'm going to do the same thing for that negative 3. And remember, when I'm drawing these lines, it just means that at the end of each line, I am going to be multiplying those 2 terms. So I'm going to take 5x, I'm going to multiply it by 2x squared, I'm going to continue with 5x multiplied by negative 6, and then I'll continue with 5x multiplied by positive 12, similarly on the denominator, or on the bottom half there. So I'm going to take 5 times 2, that gives me a nice 10. I've got an x times an x squared, that's going to give me an x cubed. I'm going to move along down the line. I get 5 times negative 6, that gives me negative 30, and I have an x times an x, that gives me an x squared. Next, I have 5 times 12, which is going to be positive 60, and x itself doesn't actually change in quantity because 12 is a constant. I'm going to continue on the bottom. Negative 3 multiplied by 2 is negative 6, and then I keep my x squared there. Negative 3 times negative 6 is a positive 18, and again, I have one x here, no additional x's or no increases. And then negative 3 multiplied by 12 is going to equal to negative 36. So again, I'm going to collect my like terms. It's not as nice as when we did the distributive property in question A, because they are actually nice and in nice neat order, but here they're not. I see minus 30x squared and minus 6x squared are like terms. And then I can see positive 60x and positive 18x are also like terms. The constant, again, does not have any partners here or collecting like terms, so we'll keep the minus 36. And similarly, that happens with 10x cubed. There are no other x cubes, so you cannot collect those like terms, but I can combine negative 30 and negative 6 to be negative 36. And the like term was an x squared. I get 60 and 18, both positive, so I'm going to get positive 78x. And at the end here, my constant minus 36.